Hello guys, welcome back to my YouTube channel. So we all love physics in all its forms, and also we show some interest to know about the new laws, new concepts. So today we'll be discussing some topics and let us know the real physics laws behind those. So the first one is how apples get their shape. Physicists say that universal theory that describes everything in this nature is beautiful. Now, coming to the point, we mostly eat apples and we also remember the great saying, an apple a day keeps the doctor away. But we never thought why the shape of an apple in that particular way only. So, why it is not in the shape of an orange, watermelon, or pineapple. And also, why there is a small dip at the top and also the bottom. So, the next time when you are about to bite an apple slice, the first question that comes to your mind should be why it is in this shape only. So, to know about it, you must open it and know the cross section of an apple. So, guys, consider this picture and also keep a keen eye on the central part of the picture. Looking at the center part and also look at the right spot, you will observe that the stem cavity where the surface dips down to meet the stem is so sharply sloped that nearly it becomes a vertical line. So this is called a stem cavity of an apple. Mathematicians and physicists have been using singularity theory. This theory states that at a particular point, the mathematical object will be no movement or it will be as a constant. So this is known as singularity theory. Here, Michael and Madhavan, applied mathematician and physicist of Harvard University, predicted that singularity theory could describe apple's cusp shape. But in order to test it, they need to know that when the cusp is formed and how. They collected and studied 100 apples at various stages and growth over 4 weeks and found the cusp does not fully form until the last half is of development. In fact, when you look at the cross section of a very young apple, it's particularly like a circle. The cusp formed only when the apple matures. So at the peak of its growth, cortex will grow 5 times faster than core, causing it to rapidly expand around the stem leads to the apple iconic cusp shape. So, other fruits like oranges, which grow differently, do not have the same approach like apple, said by the Michael. With their differential growth model, the team first tested it with computer simulations. So, by this study, Michael said he did not expected multiple cuts like red delicious tomatoes have. It is the one of the example of multiple cuts. So I think guys you have got a clear idea that how the apple is formed and why the shape of the apple is in that particular way only. So coming to the second one, the physics Nobel recognized the science of complex systems. Two scientists share the prize for modeling Earth's climate, while the third one is honored for discovering hidden patterns. In 2021, Nobel Prize in Physics was awarded to three scientists who greatly improved our ability to understand the complex systems. Those three scientists were Sukuro Manabel and Carl Hasselmann and Giorgio Paresis. Complex systems exist all around us, from disorderly arrangement of atoms. So, in 1960, Sukiro Manabel laid foundation to the current climatic condition, demonstrated and showed how the increased level of CO2 increases the surface temperature of the Earth. Later, Carl Hasselmann created the model linking climatic trends. He developed way to spot and delicate fingerprint of natural events or human activities show human emission of greenhouse gas have increased in temperature. The third comes Giorgio Paresis studied about the spin glass. Some atoms have property called spin, wants to point up and other wants to point down. This is the two parts of the spin. So there is no optional orientation that satisfies all the atoms. So analysis spin of glass is said in his book. So now coming to the third one, scientists make a sticky liquid flow faster than water. So water is the fastest to flow, but scientists have made something new, a sticky liquid that can fast flow than water. So in general, more viscous, that is, the sticky liquid is more slowly, it will flow. But researchers in Finland's Atalo University have shown that this behavior reverses in some conditions only. When tiny tubes called capillaries are specially treated, droplets of viscous liquids can flow inside them much faster than the droplets with less viscosity. This was relied on property called superhydrophobicity, means extreme aversion to water. But when wax or Teflon has roughness becomes superhydrophobic, capillary tubes about width of human hair. Such surface can sustain thin air layer that sheds. Tubes having superhydrophobic coating inside air layer thicker for viscous liquid droplets for low viscous water droplets. When at the end of the tubes are closed and tilted, each droplet acts as piston. The pressure difference depends on air upwards through the gap between liquid and the tube wall. The air moves upwards, pressure decreases and allow the droplets to flow down. An example of glycerol and water. Glycerol is more viscous, so it 10 times faster than water. So it flows much more faster than water. So this the fourth one is very interesting. It is about why is an empty shampoo bottle is easy to knock over than compared to fully filled shampoo bottle. Knocking over a shampoo bottle is most of us have experience or while bathing. So when the bottle is almost empty, based on the concepts such as center of mass and force of impact in a series of simple experiments, object with low center of mass is more difficult to trip over. This is in case of fully filled shampoo bottle. However, when a bottle of shampoo is nearly empty, the mass of the shampoo shifts overall the center of the mass of the bottle to high position, making it less stable. So, Jerome Lichimi, a physicist, made a pendulum by suspending tennis balls on a string. They lifted the ball to various heights, then allowed to flow against the bottle. Now, the larger the initial angle for the string, the greater the force. They experimented until they found the smallest angle needed to unlock the or knock over an empty shampoo bottle. So they found at last it was 3 degrees. So we can see the mass of an empty bottle is 40 grams, but the mass of a liquid or fully filled shampoo bottle is 340 grams. So it is little bit confusing. So this is the law behind opening of a shampoo bottle easily when it is half filled, and it is difficult to open a shampoo bottle easily when compared to half filled shampoo bottle. So for today, this is the last topic. So why ice is so slippery? So if you have ever slipped or fallen on a patch of ice, you already know ice is slippery and dangerous too. It's well understood that ice is slippery just like wet water. Less understood is that why ice is slow slippery, but there is no science behind this silkiness. Ice on its own is not actually slippery. It's friction that causes it to become silk, according to physics. The friction on ice causes a very thin layer of water to develop on top. That little bit of water laid over the icy surface is what causes the slipperiness. The thin layer of water reduces the friction of the surface, makes it more silkier. The physical properties of this layer of water are different from that of other source of water that which we drink or found in our waterways. For example, have you ever recently come understood that water is not typically good lubricant, but the thin layer on the ice is raising the question of why. Researchers at a library in Sorbonne University in France were able to conclusively demonstrate the friction on ice generates a thin layer of water, and this water is viscous as oil, which allows the ice to be slipperier. So, at temperature below freezing, the watery layer is almost imperceptible because of how thin it is. In lab test at the Sorbonne, researchers determined the layer of water generated was even thinner than expected, about 1 by 100th, as the thickness are stacked of hair means your one single hair. So you don't need to understand the science behind it to know the dangerousness of slipping on ice. Many a trip to emergency room started to slip on a patch of ice. So if you walk on an untreated icy surface, it helps you to walk like penguins do. So better to mimic than Arctic penguins when it comes to walking on icy surface to walk like a penguin. Slightly bend your back and keep the feet pointed outwards to increase the center of gravity according to the physics laws. So shuffle your feet or walk taking small steps and keep your arms out as your side to help to stay balanced. This is the all about why ice is. So guys, I think you have enjoyed today's content and you have learned a lot more about it. So next time we'll be coming with some more topics in physics, and thank you and have a nice day.